All right, this should be a super simple section for you because this is definitely a review from Algebra 2. Okay, so I'll go kind of speedily through it. So we know from the law of sines that we can write sine of A over A equals sine of angle B over B equals sine of angle C over C. You could also write the reciprocals of each of those and have little a over sine of A, little b over sine of B, little c over sine of C, all set equal to each other. Okay, so we use law of sines when we have angle, angle, side, or side, side, angle. But remember, the side, side, angle one is the one that's a little bit tricky. So that's going to be the ambiguous case. So we sketch it out. So we have triangle ABC. A is 110 degrees. B is 23 degrees. And little a, which is across from angle A, is 45. So when we set it up, we have sine of angle A, which is 110, over little a, which is 45, equals sine of angle B over little b. Okay, so we have angle, angle, side, so we're not in any danger of having the ambiguous case. So when you cross multiply, so you get b times sine of 110 equals 45 times sine of b. What am I doing here? I forgot my sine of my 23, didn't I? All right, equals 45 sine of 23 all over sine of 110, which when you find a 3 decimal approximation for it, you get B is 18.711. Okay. So this is where I usually set up my ABC. So B is 18.711. A was 45. Big A was 110. B was 23, which since we know they add up to be 180, this angle C has to be 47. So then the last thing we need to find is little c, so we set up, and we have sine of 47 all over, we don't know, equals sine of, and I always use the originals if possible, so 110 over 45, instead of using the b that I already found, just in case I'm wrong. So if you solve for c on that one, you should get 35.023. So we found all 6 measurements, all 3 angles, all 3 sides. So we've now solved the right triangle, or solved not the right triangle, but solved the triangle. Okay, so the next one says, well, it says note when we have angle, angle, side, there's exactly one triangle that satisfies the given information. So that's like the last one. An angle, angle, side, it was no big deal. Got it right away. Not a hard problem. However, in the side, side, angle, or if you spell it backwards, the one that spells the bad words, there may be 1, 2, or no triangles that satisfy the information. So if you remember, we called this the ambiguous case. So this one says, show that there could be no 2 triangles, or that there could be 2 triangles ABC with the measurements of 45, 5, and 6. So we're going to set it up, and we're going to have sine of 45 over little 5. The little side A is 5. Sine of angle C over 6. And we start solving it out. So we're cross multiplying, so we get 6 sine of 45 equals 5 sine of C, so I divide by the 5. So I have sine of C equals 0.8485. And then I do my inverse sine. So I get C equals 58.052. But we have a problem. Now that you guys have been in pre-calculus, you will totally understand this. In Algebra 2, I just kind of threw it at you, and you had trouble understanding it, but here is what is going on. If you have sine of C, so sine of some angle, equals 0.8485, on your unit circle, there are 2 locations that would have 0.8485. So not quite 1, so they're pretty steep. And they're right around there. So there's 2 angles that satisfy that. The first angle we just found. It's 58.052. The second angle is the angle from here around to this line right here. So we need to know what that is. So what do? Well, we use the fact that its reference angle is 58.052. And we do 180 minus that, right? So 180 minus 58.052 gives you that second answer, which is 121.948. Okay, that's your answer. Okay, so there are two angles for C. You could have an acute angle, or you can have an obtuse angle. And in this little drawing, I've tried to show you what you could have. So you could have this triangle, which has a 45-degree angle. I think I even used a protractor and tried to make it nice. A length of 6 and a length of 5. Or you could have this one. So if I swing this over here, I have a second triangle. And what's the thing that we're finding? So that's A. And then, so this was the little a, was 5. This has to be C because this is little c, right? So angle C could either be an acute angle or it could be an obtuse angle. Okay, so that's what's happening in these types of questions. It comes from the fact that inverse sine on our calculator only gives us one answer. There's actually two locations where that would be true. Okay. So it says show that there's no triangle. These are always the best because you set it up and you're like, oh, sine of 54 over 5 equals sine of b over b. And you're solving it out and you're like, oh, I'm feeling good about this. Sine of b is equal to 1.2944. And then you do inverse sine on your calculator. And you're like, oh, yeah, I'm going to get this answer. This is so easy. And then you're like, oh, wait, it says error. And that's because we know that on the unit circle, the highest value we can possibly have for sine ever is 1, right? That's the 0.01. So saying that sine of an angle is equal to 1.2944 is impossible. Okay, it's too big. So that's when you would have a no solution. All right, moving on. So number 3, so it says solve the triangle when A is equal to 5.9. B is equal to 7, and angle A is 27. Okay, so we're going through and we're solving this problem. So we have sine of 27 over 5.9 equals sine of B over 7. We get to the point where we have sine of B is equal to, I don't know, let me do it, 7 sine of 27 divided by 5.9. 0.5386, and we find B using inverse sine on our calculator. And we get 32.591. But we noticed that this was the one where we had a side, and an angle as we went around. So there has to be, well, if this is the ambiguous case, there's something funny about it. Red flags all over. So we get the first angle, and we always have to do 180 minus to see if there's a second solution. So we do B1 and we do B2. B2 is going to be 180 minus 32.591. So when we do that, we get 147.409. And occasionally, it won't work, okay? But in this case, it does, because if you go back and you look at your original angle, and you say, oh, I have 27 degrees. Can I have 147 as well? Yeah, 27 plus 147.409 is 174. There's still enough room. There's about 6 degrees that you could have for angle C. So it works. So these are the ones that you always love because you have lots of answers. Okay, so you can write it out. So we'll say first triangle, and we'll talk about the second triangle. So the first triangle, we have angle A, angle B, angle C, little a, little b, little c. So angle A is 27 for both of them. Okay, and B, for the first triangle, we got 32.591, but for the second triangle, we got 147.409. Okay, and then we continue to solve for the rest of the triangle. Okay, so if I subtract my 27 and my 147.409, I get 5.591 for that one. If I do 27 plus 32.591, and then 180 minus that, I get 120.409. Kind of sloppy, 120.409. We know A is 5.9, and we know B is 7 for both of them. So we only need to find little c. Okay, and if you find little c for each one, you're just going to set up your sine of angle c, which in this case 120.409, divided by little c equals sine of angle A over little a, and you should get c equals 11.208, and then you do the same kind of setup for the second one, and you should get 1.266. So you can finish those out if you'd like, but you should get those answers. All right, so it brings us to those questions that we talked about in the last section where I said they would be a lot easier if you had the law of sines. So it says two surveyors standing at points A and B are measuring a building. The survey at point A is 20 feet further away from the building than the surveyor at point B. The angle of elevation to the top of the building from A is 58 degrees, but from B, since they're closer, it's a steeper angle, right? 72 degrees. So how tall is the building? So we want to find h. So you could do this the way we did last time, which is where you find another variable, which is like x, right? And you could set it up, and you could find x and you could find h using substitution or elimination. But let's say we don't want to do that. Well, we can do law of sines as long as we use the side that is shared in two triangles. So we have that side right there, which is very important to us. Okay, that's what I'm going to make my x. I can find, if I know I have 72 degrees down here, I can find this angle. So it's 108 degrees, which allows me to find that angle, which is 14 degrees. So I can find x. I can find x with the law of sines. So I say sine of 58 all over x equals sine of 14 all over 20. And I pretty easily find x, which is 70.109. So I'm going to keep that on my calculator. Now I'm going to talk about this other triangle. It's the red triangle. Okay, I now know my x, so now I can just do SOHCAHTOA. So I want to find the opposite, and I have the hypotenuse, so I'm going to do sine. So I have sine of 72 degrees equals opposite over hypotenuse. And I multiply it over, and I get h equals 66.678 feet. And that is the answer. So see how much faster that is instead of using substitution or elimination if you use the law of sines. Okay, the area of a triangle. So it says the area of any triangle is 1/2 the product of the lengths of the two sides times the side of the sine of their included angle. So in other words, it could be 1/2 A times B, and then sine of the angle between them, which is C. Or it could be 1/2 B times C times the sine of A. Or it could be 1/2, what did I have not used? A times C, and then the sine of B. Okay, it can be any of those three forms. So why is this? Because if you try to prove the law of sines, which I'm not going to do, I don't want to bore you with that. I know these are thrilling lessons as it is. The height of the triangle was h equals b times sine of a, which you can see. So if you have the height, you talk about this, right? You're going to have sine of a equals h over b. So b times sine of a equals h. Okay, therefore your area, which we know is always 1/2 base times height, ends up being 1/2 base is C times the height, which was B sine of A. So that's where it comes from. And it doesn't matter if you talk about like an obtuse triangle or whatever, it's the same thing, your height and your base. So that's where the formula comes from. Okay, so it says find the area of the triangle shown in the figure below. Okay, these are very easy questions. It's just 1/2 5 times 6 times the sine of 153, which you can put all in your calculator all at once, and you get that it's 6.810, and since it's an area, I'm going to say centimeters squared. Okay, but that's not the only formula for the area of a triangle. Sometimes you don't have the angle between two sides. Maybe you have three sides. Okay, so if you have side, 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 you're trying to figure out how to find the area, you can do it with this formula, which is called Heron's formula. Okay, so S is a number that you find first before you even begin. It's almost like the average of the numbers, but it's not. So instead of adding all three numbers together and dividing by 3, we don't divide by 3, we divide by 2. So it's going to be 8 plus 10 plus 14 divided by 2. So we get S is equal to 16. So if we want the area, you're going to have S out front, and then you're going to have S minus each of the numbers. Oops, 16. So 16 minus 14. So your area, when you simplify the inside, you get 1536, which you could reduce that square root, but I'm guessing like if you had this in Math Excel or even on the test, you could, I'd say round to 3 decimal places, or Math Excel might say round to the nearest hundredth or whatever. So in this case, I'm going to round to the 3 decimal places or the 1,000. So I get 39.192, and I don't have any units, so I'll say square units. Okay, and then the last thing we're going to talk about is law of cosines. And these questions can also be a step up from Algebra 2, so I mean, you're going to have some tricky ones. The thing to remember with the law of cosines is that if you have side, 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 you must find the largest angle first. So that's the first one. So we need to find R first, just because if it's obtuse, when you put that first, like when you put your 90 squared first, you're more likely, not more likely, you will find that it's obtuse. So you get 90 squared equals 70 squared plus 40.5 squared minus 2 times 70 times 40.5 cosine of angle R. Okay. And the trickiest part about this is people forget that all of this is together and they just do the numbers. So maybe put brackets around that and then subtract these two numbers over first. So when we do that, you're going to end up getting to the point where you have cosine of R equals negative 0.2751. So when you do inverse cosine, you get R equals 105.967 degrees. Okay, and then it says find all the angles, so then you would find the others with law of sines. I'm not going to waste your time with that, but you could find each one if you wanted to. All right, so next one says to find the distance from the house A, the house at point A to the house at point B, a surveyor measures the angle C, which is found to be 50 degrees, and then measures the distance to each house, which is 50 and 90 feet, respectively. So if you've ever seen someone with those little orange, they look like cameras. Those are surveyors. Surveyors are actually paid quite a bit of money. It's a good job, but it involves a lot of math, which is a good thing, right? I love math. So it's an interesting job, but they're going to find the distance across lakes and hills and so on. So say we have this distance here. So we're going to set it up and we're going to say that cosine, well, not cosine, let me start out with the, so we're going to say C squared equals 50 squared plus 90 squared minus 2 times 50 times 90 cosine of 50 degrees. And you can put all of this into your calculator all at once, so you'll get 4,814.9115. So when you take the square root, you get 69.390 feet. And that is your answer. Okay, the next one's a little bit tricky. The picture doesn't help very much. So in math class, I find that the best way to draw a picture is to really exaggerate it. So it's kind of tricky to know what's happening with this tower because it looks like it's like 90 degrees here, and it's not. So let me explain what I mean by that by drawing a better picture. Okay, so I'm going to exaggerate the angle. So I'm going to make it much steeper than an actual 7 degrees. So let's say we have a hill, and this is 7 degrees. Okay, if we have a tower on the hill, the tower will not look like this. Okay, imagine building a house or something that looks like that on a hill. Okay, everything in your house would roll down the floor. It would not be level, right? So we can't build anything going off the hill like that. We have to build it going straight up, okay? So it is not a 90-degree angle like you would think. It is not 90 degrees there. Okay, it's something else. So we need to figure out what it is. Okay, so we have 7 degrees. And if we drop this line down, there is a 90-degree angle at kind of like the base of the hill, right? If I could dig through there, there would be a 90-degree angle. So that means that I would have 83 degrees here and also 83 degrees here by vertical angles, right? So if I wanted to find this missing angle, it would be 97 degrees. So in the problem, it says that we have an 800-foot tower on the side of a hill that forms a 7-degree angle with the horizontal. Find the length of each of the 2 guy wires that are anchored 100 feet uphill and 100 feet downhill from the tower's base and extend to the top of the tower. Okay, so these guy wires are not going to be the same length. Okay, so one is going along here, and this distance is 100 feet. So we want to find that length, which we'll call x, and the other one is going along here, which is also 100 feet, and we want to find that distance, which we'll call y. Okay, so we can use law of sines or law of cosines. In this case, it is the cosines. Okay, we know this is 800 too, right? The tower is 800 feet, it said. So in order to find x, I say x squared is equal to 100 squared plus 800 squared minus 2 times 100 times 800 cosine of the angle, which was 97 degrees. So when we do that, we get x equals, well, x squared equals 669,499.0949. So x equals 818.229. So that's how long the first one is. I think it was feet, right? Let me look. Yes, feet. Now y. Y is the same idea. Y squared is going to be 100 squared plus 800 squared minus 2 times 100 times cosine, or times 800 times cosine of not 97 this time, 83. So when you solve for y, it ends up being just a little bit shorter, which makes sense because it's on this hill, right? You can tell from my drawing that y looks shorter. So it's going to be 794.041 feet. Okay, so that's how you do that one. I just wanted to make sure that you understood this drawing because I think, like, I started the problem on my own paper, and I was a little confused at first. I was like, wait, this drawing makes it look like 90 degrees. It's very confusing. Okay. All right, and there might be some where you have to sketch it out as well. So this last one is like that. So it says ship R leaves port P and travels at a rate of 16 miles per hour. Another ship Q leaves the same port at the same time and travels 12 miles per hour. Both ships are traveling in straight paths, and the angle created is 55 degrees. So the angle between them is 55 degrees. So how far apart are the ships after 3 hours? There will be a lot of problems where they don't tell you exactly what this distance is. You have to find it. So after 3 hours, if you're going 16 miles each hour, you're going to have 16 times 3 here, which is 48. And for the other one, if you're going 12 miles per hour, you're going to have 12 times 3, which is 36. So if you want to find the distance between the two, well, it's the law of cosines, right? So you're going to have, I'll call it P. So P squared equals 48 squared plus 36 squared minus 2 times 48 times 36 cosine of 55. And if you solve for P, so I'll let you do all the math, you should get 40.221 miles. Probably nautical miles per hour, right, like we learned about before, but we'll keep it as miles. Maybe it really is miles. All right, so that's the end of that section. So hopefully that was pretty easy for you. Obviously, the problems are getting a little bit harder than what we did in Algebra 2. There's a lot more story problems, but I think you guys are totally capable, and I'm sure that you're doing very well and very prepared for our upcoming test.